Okay, here we go. Hopefully you don't have too much of an issue sketching what's happening here. This is the parabola y equals x squared minus 5x plus 9. I just kind of graphed in the axis of symmetry, which is halfway between 1 and 4, because this is y equals 5 is a horizontal line. For any point x value between 1 and 4, this point right here has a y-coordinate of x squared minus 5x plus 9 because it lies on the parabola. And that is this distance right here. That means that this distance is the height of a typical shell right here. So that's h. And the distance from the axis of revolution to the center of that shell is the radius of the shell. So this is a typical cross section right here. We need expressions for h and r in terms of x. Well, this h is a vertical distance, and it's actually the difference between this y-coordinate and this y-coordinate. In other words, this whole segment has a height of 5, but if we take away this part, we'll have the height of the shell. So h equals 5 minus that quantity. And if I remove the parentheses, minus x squared plus 5x minus 9, which becomes negative x squared plus 5x minus 4. Now, r is the distance from the axis of revolution, which is the line x equals -1, to the center of the shell. Well, this distance right here is x, and this is 1. You can calculate that distance because that's a horizontal segment by saying the x-coordinate at the right minus the x-coordinate at the left. So r equals the x-coordinate at the right is x minus the x-coordinate at the left is -1. So an expression for r is x plus 1. Okay, so let's see. We sketched it. We kind of, this is not really the cylindrical shell. You have to visualize this like the shell of a pipe as this cross section is revolved around that axis of revolution. We've got an expression for the height in terms of x. We've got an expression for the radius. The circumference is just, well, the base is going to be a circle, and the formula for the circumference of a circle is 2 pi r. So we're going to create infinitely many shells from 1 to 4, and we want to really find the volume of that shell and then add them together, and that's where we have the definite integral. So we've got 2 pi. The volume of a cylinder is the, well, let me do it this way. 2 pi times 1 to 4. The average radius is x plus 1. And the height is the opposite of x squared plus 5x minus 4. dx. Okay, so that's what you want to calculate right there. Now I'll send you a link to a Desmos graph that does this calculation. But to do it, you're going to have to multiply these two polynomials together, then find an antiderivative term by term, and evaluate from 1 to 4. Okay, there you go. Hope that helped. If you have any questions, post a comment.